Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss the design process of the key or design process for the shrunk key. Now friends, first step in the design process of the shrunk key is the selection of the key material. Generally, plain carbon steel is selected as the key material for the manufacturing of the key. So you can select the plain carbon steel as the key material. Suppose I am selecting the plain carbon steel 50C8 designation as my key material, whose yield strength in tension is equal to 460 Newton per mm square. So you have to write down the value of this SYT, that is the yield strength in tension for the key material corresponding to the key material, and from your design data book. This is a very important data. So this is the first step. Now the second step is the permissible stress calculation. So you have to calculate the permissible crushing stress and permissible shear stress for the key material, because basically key is subjected to the crushing stress and shear stress. So permissible crushing stress can be taken as 2 into SYT, that is the yield strength in tension, divided by factor of safety, where factor of safety can be taken as how much? 3. And the permissible shear stress can be denoted by tau s, is given as 0.5 times SYT divided by factor of safety, where factor of safety can be taken as 3 and SYT can be taken from here. You have to take the value of SYT from design data book corresponding to the key material. Okay, and after that you have to put the value of SYT here and here to get the permissible crushing stress and permissible shear stress for the key material. The next step is the key dimension calculation. Now friend, you have to go to your data book, and in the data book you have to see the dimension for the shrunk key. This is the table available on all data books. So first of all you have to see the dimension of the key corresponding to the diameter of the shaft. So you have to find out the diameter of the shaft first. After that you have to, on that basis you have to find out the dimension of the key. So suppose our diameter of the shaft is, suppose 11 mm. Okay, so 11 mm is lying between 10 mm and 12 mm, where D is the diameter of the shaft. So if the diameter of shaft is 11 mm, it is lying between 10 mm and 12 mm. Okay, so our dimension of the key will be 4 into 4 into 2.5, where 4 is the width of the key and 4 is the length of the height of the key, and 2.5 is the depth of the key. Okay, so these are the dimension of the key. So you are now able to select the dimension of the key based on the diameter of the shaft. Based on the range of the diameter of the shaft, you can select the dimension of the key from this table. Now after that you have to find out the length of the key. The length of the key can be given as by using this empirical relation, as length of the key is equal to 1.5 times into diameter of the shaft. Now once the diameter of the shaft you have calculated, now what we have to do, you have to check for the crushing failure of the key and check for the shear failure of the key. Now you have to calculate the shear stress induced in the key. So the shear stress tau being induced in the key is given by 2T by dBl, where T is the turning moment acting on the shaft. So the shear stress induced in the key is given as 2T by dBl, where dBl are the dimension which we have already calculated. Okay, so after getting the value of tau, that is the shear stress induced in the key, from this formula you have to compare the value of this tau with this value, that is tau s, that is the permissible value of shear stress for key material. If this value of tau is coming out to be lesser than tau s, then we can say that the design is safe. Similarly, you have to calculate the crushing stress induced in the key, given by this formula, where T is the torque acting on the shaft material, then you can get the crushing stress by using the dimension of the key DHL and the torque acting on the shaft. And after that you have to compare this value of crushing stress induced in the key with the permissible crushing stress for the key material from this above data, that is from step number 2. If this value of sigma c is coming out to be lesser than this value, okay, that is, suppose this is sigma c k, okay, suppose this is sigma ck, and this sigma ck is coming out to be lesser than sigma c, then we can say that the design is safe. So this was all for today's video, and friend, if you like my video you can subscribe my channel and also press the bell icon for the notification of the upcoming videos. So thank you friend for watching my video.